Okay, welcome everybody. Here we go. I think everything's set. So, looking things over, it looked to me like most people did pretty well on the exam. That's good. And looking at the homeworks and stuff, it seems like more or less people are in a good place with the class. So here's what I'm gonna say. I'm not going to put out a retake unless it's asked for. So you don't have to ask in class, right? If you're someone who's like, oh, I wanted to do the retake, but I don't want everyone to realize I'm someone who needs to take a retake or something. But by looking over the grades, I'm not sure anyone is even going to do the retake. So I'm not going to build the test unless someone asks me to. So remember how I mentioned there would be the retake option? Oh. Sorry, I just realized they didn't unmute Zoom, so the people in Zoom couldn't hear me. So what I was saying is the scores are pretty good for the exam. So unless someone asks me about the retake, I'm not going to build the retake. So if you have a score, because as far as I can tell, the people who are still participating in the course passed the exam, but they're not all perfect scores. So if you're someone who wants to try to take another shot at the exam, let me know, but do it like immediately so I can go set it up, because we're not going to do it like a month from now. It's not like at the end of the semester you're going to go, well, I'd really like to retake exam 1. If there's going to be a retake for exam 1, we need to do it now. I told you there would be, but like I say, I'm not even sure anyone's going to want to take it. So I'm not going to build the test unless I think there's someone who's actually going to take the exam. So if you're someone who you're sitting there and going, no, I think I want to do the retake, send me an email, and then I'll build the retake, and then I'll tell the class that they can take it. Okay, so, but otherwise, I'm just looking at it. I'm kind of assuming that maybe no one's going to take it. But like I say, let me know, right? I'm totally willing to build the test and release it, just like I said I would. But I don't want to do that work if no one's going to take it. If 0 people are going to take the retake, why would I build it, right? So no, and don't worry. I know sometimes people are certain students are afraid to talk to the teacher or something like that. Like, don't be intimidated. It's not a big deal. It's not a problem at all for me to build that retake exam if somebody's going to take it. Okay, even if only one person's going to take the retake, I'm perfectly happy to construct that retake and make it available for students to use. Okay, but I don't know if anyone's going to use it or not. So don't let that be an issue for you. And then moving forward, I think we're in a really good place as far as time. We only have 3 more. Oh, here we go. Let's see. Oh, looks like maybe I have to update some assignments to have some due dates wrong. I will make a list of that and fix that. So let me check my due dates. Put that right. Okay, so first thing I will do after class is I will check the Math V01 due dates, and I will update specifically exponents and polynomials. Okay, so no sweat. I will. I'll go back and I'll double check the dates from here on out, and I will update those. So thanks, William, for bringing that up. I will look into that and take care of it after class. So what I was getting at, because that actually relates to what I'm talking about, which is we have plenty of time. We have essentially only 3 chapters to get through, and we've got like 40% of the class left or something like that. Let's see. So let's take a look. So if we go over here, they changed everything around again, so it's all in different spots. They really like to move things around here. Yep, they moved the schedule now, or the calendar. Here we go. They move. It's like sometimes when Apple does an update, and they update something, and like all they did was move the buttons somewhere else. They didn't really update much, but the buttons are in a different place, and you got to figure out where's all the buttons now. They moved the play button from like here, and then they hid it inside this other thing. It's kind of what our school keeps doing. Okay, so academic calendar is now over here. It used to be on the right side. So now it's under here under admissions. So you click academic calendar. And let's go down to 2021, 2022 instructional calendar. And we're doing what? October 19th or something? Is that where we're at? October 19th. We're in week 10. So we're a little over halfway. So we've got 1, 2, 3, 4, 5, 6, about 7 weeks left of instructions. That's good. That leaves us over 2 weeks per. Right, thanks. That leaves us about 2 weeks per chapter, roughly, a little more than 2 weeks per chapter. There's a little bit of a couple holidays in there, so we're going to miss a couple of Thursdays. Let's see, let me move this up so everyone can see since it's relevant to you all. See, in November, we only meet for 2 Thursdays because we get 2 Thursdays off. So just be aware of that. But that should give us plenty of time to work through the chapters, especially since 2 of those units are really kind of related to each other. The next one we're going to do just naturally flows into the other one. So that'll just kind of in your minds probably be one big topic, which is polynomials, right? We look at all the basics of polynomials, and then the next chapter, which I think could be argued as one of the most important topics in the class, is factoring. And that all just kind of goes together. The multiplying and the factoring and all that kind of stuff just kind of fits in a way that makes sense. So we'll do that. And then you've got your final exam at the end of the semester. So we don't have to rush or anything like that. We can take our time. So that's nice. We can take our time. You can bring questions to class. You can ask me questions. Seems like everyone's doing pretty well. So that's good. But we are definitely not going to have to rush through things, which is good, because once we start doing that, then students start getting left behind. We don't want that. Okay, so where are we? So we're kind of looking at we're building up the basics of polynomials, which includes understanding exponents. Once we start to understand exponents, it's going to inform us as to how to deal with scientific notation, and then how to use polynomials, right? Now, the good news is we're going to start off here learning exponents really in depth. But for polynomials, you only need a couple things about exponents. Like, you're actually probably going to find the basics of polynomials is easier than some of these problems with exponents, because they can get a little bit tedious. So that's what we're going to start with today. Oh, and there's something I forgot to tell you. So and this actually might work, although I haven't really been having too many students from this class show up to my office hours. But the Monday office hours, which the school had been forcing us to do 3 hours on campus, the school has sort of realized that those of us professors who teach 100% online, what's the point of having on-campus office hours for people who are taking online courses, right? So they finally decided to let us have all of our office hours online. So my Monday office hours are now online. So 11 to 2 on Mondays. If you want to come to office hours, you can, just on Zoom. So it's your normal Zoom link will get you into office hours, and I can help you with anything that you need, okay? So people were I think I had 4 people so far all semester show up to Monday office hours. Because you got to get on campus, and then you got to get through screening, and then you got to find where I'm at, and all that. It's a lot of hoops, and most people skip that. But if you want to come to office hours Monday 11 to 2, you can, as well as I always have office hours right before this class, Tuesday and Thursday, right before, but like in between my 2 classes, I have office hours. So at any of those times, you're welcome to show up into Zoom and get help from me. Okay, whether it's you're scared about the class, it's getting you nervous, you're scared about a certain topic, you have a homework problem you can't do, any of that kind of stuff, come talk to me. I'm going to help you through it, and then you're going to figure out how to do it, and then pass the class, right? So don't, if anything starts bothering you, just come talk to me. Okay, like I was saying, we are going to start work with looking at exponents. And that's kind of the hardest thing of this next unit. So we're starting off with the hardest thing. And then once you get through the homework on exponents and stuff, it'll get easier. In fact, let me just go ahead now so we can look at some of them. Let me change some of these. Let me change the dates on some of these. Those are all right. Yeah, let me just change these now while we're looking at them. I think, is it going to let me do it in here? No, it's okay. Let me it's going to make, I don't want to expose anyone's grade on accident, so let me do this off screen because I'm actually going to pull some of them up today. I didn't realize I had the due dates done poorly. So let's go to assignments, math 1. And what did we have here? Oh, here we go. Found them. Okay, and some of you have already done these, but let's change that due date for this one. Oh yeah, it was just due a couple days ago. Let's change that to be more like here. And then there should be, let's see, I think there's one more that needs to be changed. Let's see, this one should get changed. And let's see. I wish there was a little bit easier to screen to see when all the due dates are. When's this one due? Well, let's go ahead and move this one out a little bit too. Although this one's not too bad. Okay, let me just double check what the rest of these look like right here. Okay, so I moved a couple of those. I think we're probably good on due dates. If you see anything else that looks like it's problematic as far as due dates, let me know. Everyone in this class that's still participating seems to be working pretty hard. So, you know, I don't mind being a little bit flexible with people who are working really hard. The time as a professor when it gets difficult is when students don't do anything. They'll like put in 0 effort and then they're like, "Can you give me an extension?" So, well, why do you deserve an extension? You didn't do anything. But if people are obviously working hard, which it seems like we have a class here where people are working pretty hard, you know, as long as it's keeping us on track to be successful, I don't mind being a little bit flexible. So if some kind of due date looks like it's not right, let me know and we'll look at that. So let me update this actually. This screen actually would help me. Oh, that was a weird screen I just had. Let me see. Sorry, I was going to do this after class, except we're actually going to talk about some of this stuff, so I don't want to leave it sitting. So let's see if I go sample student page, Math 01. Yeah, there we go. Yeah, we have plenty of time. Okay, good. I think that looks right now. So, so we're going to be dealing, thanks for pointing that out, William, so we could set that all straight. So we have to learn how to deal with exponents, right? Now, that sounds easy, right? Because you're like, well, I know what an exponent, it just means that's how many times you multiply the thing. Like 5 to the third means I multiply 3 5s together, right? 5 times 5 times 5. That's the basics of what an exponent is. But when you get deeper into the algebra, these exponents can actually start to get very complicated and turn into things that seem like they don't even make sense, right? Like a negative exponent. So 5 to the third power means I multiply 3 5s together. what does 5 to the negative 3 mean? How do you multiply negative 3 5s together? What does that mean? Does that mean I put the negative on the number? No, it actually does not mean that. So it gets a little bit confusing. And then we won't do it this semester, but next semester, you're actually going to get into fractional exponents, which is even a little bit more weird to visualize. Like, so 5 to the 2/3 means I'm going to multiply 2/3 of a 5 together. What does that mean? Right? So a lot of it kind of stops making sense. So we start off with this very intuitive understanding of exponents, and then it's like going into Wonderland or something. Things just get weirder and weirder and weirder the farther you go with it, and everything starts to get kind of bizarre. So we're going to get a basic understanding of exponents right now, and that's going to allow us to deal with polynomials. And later on, let's see, the thing we end the semester with is rational expressions. So we'll do that, and then next semester you'll get even more practice with this kind of thing, okay? So we'll go from there. How do we evaluate expressions with exponents? So this isn't too bad. A problem like this, you're just using your basic order of operations, right? So in other words, you've got some multiplications, some additions, you've got some exponents here. Remember, you just remember your order of operations. I do exponents first, right? We do parentheses first, but there's no grouping symbols in here. So the first thing I would do is exponents, so you do those. Then you go through and do your multiplications, and then you do your additions. The problems that people do is they'll go, oh, like 6 plus 6 is 12, and then they'll multiply 12 times 3 and then square that. Well, you did your addition before your multiplication, and then you did a multiplication before an exponent. So just fall back on those order of operations that I believe we did in the first chapter of this semester. So a little ways back, but you've been using order of operations pretty naturally in the problems that we've been doing, but they're gonna play a bigger role now. So make sure you're paying attention to those. So just do exponents first, then your multiplications, then your additions, right? Remember to do them in the right order. So let's see, that should be, well, let's see. If you have questions with that one, come see me, and then we'll get into things. So let's look at some, let me double check something here. I think we're missing an assignment. How is an assignment missing here? Let me double check something. We did a little bit of exponents at the beginning in your order of operations. So first thing we did in the whole class was order of operations. So make sure you see that. I'm somehow missing an assignment that should be in here. So I'm going to have to add an assignment. That's okay. We have a ton of time before we need to get to the next stuff. But I need another exponents page. So there's going to be an additional assignment that's going to pop up in here, just so you know. Somehow I'm missing one, and I'll have to go figure out what happened to that, which is actually the next one that we need to do, which is how I know that it's missing, because it should be in there. Okay, so here's the thing. What we do is we develop a series of rules for exponents. Really just theorems is all they really are, mathematical theorems. But what we need to do is come up with a set of rules for how to deal with exponents in different situations. And sometimes what I'll start off with is some simple examples, and you can always do this, right? A lot of times students get to the point where they're like, wait, is this where I'm supposed to add the exponents, or is this where I'm supposed to multiply the exponents? And they can't remember. What I'm going to show you is how to make a simple little example for yourself. Like over in the margin of your paper, you can make an example, and you can think your way through the problem, and then you'll be able to remind yourself. So, you know, there's so much emphasis now. It seems like students coming out of the K-12 system, especially right when they get out, what they've been trained to do all those years in mathematics is memorize, memorize, memorize. But that's actually the opposite of what you want to be doing. A few things you have to memorize. What you want to be able to do is think your way through problems. If you're just going through these math classes memorizing things, then the reality is you're not going to remember them even a year from now, right? So you take no math for a year, someone puts these problems in front of you, you're going to go, I don't remember. But if you can think your way through the problems, if you understand them, then you'll always have that knowledge because you can just make a little example for yourself and go, oh, that's right. That's how you do this, right? So for instance, let's do some basic exponent stuff. So, we know that 5 to the third means 5 times 5. Actually, that works. Let's use that symbol, 5 times 5. So exponents 5 cubed just means 5 times 5 times 5, right? So since it's a multiplication, that makes sense that it comes right before multiplication in the order of operations because powers really essentially are a multiplication, but they're a special one that we have to make sure we do in the right order. So it comes first. And we can have the same thing, except with a variable. That's perfectly reasonable. So, we can make this x cubed is x times x times x. It works with variables the same way that it works with numbers. That's perfectly fine. Okay, so that all makes sense. All right, so what happens if here's our first rule we're going to investigate. What if I run across something that is x to the n times x to the m? Oops, that's not right. And is that going to be big enough on the screen? Yeah, as soon as it fixes itself, that'll look fine. There we go. Okay, so the question is, what do we do here? Now notice that the bases are the same, but the exponents are different. How would we combine these? How would we simplify these? Well, here's what you can do to just make yourself a simple example and try to remind yourself, what is this? So I'm going to make the simplest example I can come up with that's really meaningful, which would be x squared times x cubed. I want to multiply x squared times x cubed. How is that simplification going to work? Well, let's just think about it in terms of what we already know. That's what you always do with these rules of exponents when you get stuck, is you break it down and think about it in terms of how does this fit in with the things that I'm already aware of, right? So x squared is what? That's x times x, and x cubed is what? X times x times x. So x squared times x cubed really looks like this right here, right? Here's my x squared, and here's my x cubed. So what do we really have going on here? We really have 5 x's being multiplied together, right? And how did we get 5? Well, we took the 2 from the first part and added it to 3 from the second part to give us a total of 5. So it turns out, by looking at our simple example here, we were able to convince ourselves that what I'm supposed to do in this situation is add those exponents together, right? And this is when you add exponents, when you have the same base. All of our rules of exponents involve the same base, right? Once you get into different bases, that's a much more complicated situation. We're talking about the same base in this. So the base, you've got your base and the exponent. So this tells us, oh, this is the case where we should be multiplying together. So this would just be x to the n plus m. So whenever you want to simplify something that's of this form, you add those exponents together, right? And obviously, we don't write it as 2 plus 3 over here. We write it as 5. We simplify it to what we know it is, right? It's in its fully simplified form. So that's our first rule of exponents. And this is actually the one we're going to use a lot with polynomials. Okay, our polynomial work will involve adding exponents very, very frequently. Not all the time. Sometimes the exponents stay the same, like when you're adding things together. But when we get to multiplying, which will be probably sometime next week or the week after, depending, that's when we're going to start adding exponents a lot when we're dealing with polynomial operations. Okay, so that's kind of your first rule. Okay, now let's look at what would our next rule look like. So let's say I've got what if I've got something that's x to the n, and that's being raised to the m? So here, what do I have? I have a base being raised to a power, and then that whole thing is being raised to a power, right? So again, what are we going to do? You go, why don't I make myself a small, simple example that I know I can work through, and then that's going to help me figure out how to do all of these types of problems. This is literally what people do when they do mathematical research. You have a problem that you're supposed to solve, and like when you're doing your PhD, you're working on work no one's ever done before. It's like brand new mathematics that you're creating. So you can't just look it up in a book and go, how am I supposed to do this problem? No one's ever done that problem. You're the first person to ever solve that thing. You got to figure out how to do it. So what do? You try to break it down into smaller problems and go, what if the problem was like this? How would I go through it? And then you learn something. Okay, what if the problem was like this? Okay, what would I do? And you just think your way through it, and eventually you solve the big problem that you're working on. That's literally like how you do it. Okay, so all right, well, let's make ourselves an example then. So what if my problem was x squared cubed? So see how I'm using small enough numbers that it's pretty basic, but they're still, they're not like ones up here, which can be kind of sort of confusing to people sometimes. So it's a pretty basic idea. So just break down, well, what does this mean? Well, x squared cubed, the cube means that whatever's in the parentheses, I multiply 3 times, right? I go, okay, so that really means x squared times x squared times x squared. All right, that's what x squared cubed means, is that I have x squared times x squared times x squared. Well, how do we simplify from here? Well, you have 2 ways to do it. You could break down each of those x squareds into x times x. If you forget the rule we just figured out a minute ago, that's totally fine, because how many x's would you have? 6. Or just fall back on the rule we learned up here and say, oh, this is that case where I'm supposed to add the exponents together, right? Doesn't this look a lot like this rule up here? Oh, I better add those exponents together. So either way you think about it, you get x to the 6th, right? So now that we have x to the 6th, so what does it look like we had to do to get from here to here? Well, it looks like for each number down here, we had this many x's, so that should be multiplication. And yeah, that works. 2 times 3 is 6, so it looks like our pattern is holding. So it looks like this is where we multiply things, and in fact, that is the case. This is equal to x to the nm. So that's when we multiply those exponents together. Okay, so you want to get comfortable with these and recognize, when do I add my exponents? When do I multiply my exponents? People will mix those up. If you can keep those 2 straight right out of the gate, a lot of this next 2 chapters will be a lot easier for you. Okay, because what's going to happen is when I find that assignment in here, or somehow it got deleted or something, when I put that assignment in here, you're going to have a lot of different exercises that have to do with simplifying things that have all these exponents in them. And you're going to have to use all of these exponent rules in order to go through and figure out how to do those. In fact, next time we'll take a closer look. I don't know, we might finish the exponent rules today, but we'll take a look at some of those cases, and we'll look at some of those problems. Okay, so let's look at the next rule, and this is another one where it's pretty easy to come up with an example that's going to help us work our way through it. So let's say I've got a fraction this time. Don't get too worried. There's going to be a lot of fractions in this chapter, but they're not scary, trust me. So let's just say I've got x cubed over x squared. Right? Oh, whoops, that's my actual example. The rule we're trying to figure out is, how do we simplify x to the n over x to the m? How does something like that simplify? I think sometimes what happens with people is, in these classes is we show you an abstraction. Like this is kind of an abstraction. It can mean any combination of n's or m's together. And then people get so locked into that abstraction that they don't think about actual cases where they're doing the problem. So you want to be able to bounce back and forth between abstraction and specific values that you can figure out, because this problem's not too bad, right? This is really what we've got: the fraction xxx over xx, right? That's really all this means. X cubed over x squared just means we've got 3 x's on top, 2 on bottom. Well, what if you were going to go through and start canceling these? Right? So you divide the top and bottom by x, and then one of those x's is gone from the top and bottom. Then do it again. So when we start canceling things out, we're really going to be left with what? We're going to be left with the fraction x over 1. Because, you know, these x's can cancel. These x's can cancel. You're left with 1x on top, and we don't have 0 on the bottom. People make that mistake. Oh, yeah, I got rid of everything in the bottom, so it isn't at 0. Remember, when we're canceling, like canceling is not really a mathematical operation. When we use that term cancel, what we're doing is dividing. When you divide x by x, you're left with a 1. So it's x over 1, which, of course, we know is x, but the point is, and we don't usually write this as x to the 1, but I'm doing this as an example that we can see what's going on. What happened with our exponents? Well, for every variable we had in the numerator, we canceled it with 1 in the denominator. So we're going to end up with whatever this exponent is up here minus the 1 down here, and sure enough, that worked. 3 minus 2 equals 1. So this really becomes x to the n minus m. Okay, x to the n minus m is really what you do. So in that case, you subtract the exponents. Okay, those are your 3 basic starting rules of exponents that we can get into. And I actually, with the time left, I want to see, I was going to pull up that one. I don't think this one's going to do it. Yeah. Yeah, they're going to keep being like this with their order of operations. Let me see if I can actually, if I just make that assignment right now. In fact, if I do it over here, give me 1 second, because the way Delta Math works, if I'm not careful, I'm going to expose everyone's grades, which I shouldn't do. So let me just pull up this thing real quick. And then we can do some problems. Don't want those. There we go. Exponent rules. Oh, here we go. So somehow I missed. I don't know where this assignment went, but let's see. Yeah, so you'll see, here's some types of problems like we were just looking at, right? So if we use some of those rules, so here's what you have to do is you have to ask yourself, okay, what did, which exponent rule should I use? I know you've only known them for a few minutes, but you know, you look at the rules I just showed you and you go, did we have a rule that looked like that? Yeah, we did, right? If we come back over here, that is like this one. Right? It looks like this, where we have x to a power, and it doesn't have to be x. It can, in this case, it's m, or it could be a, it could be a number. If it's a number, you're actually going to calculate what that value is. But in this case, it's an m. So we're going to go, okay, that's where I'm supposed to multiply exponents. So you come back and say, okay, that should be m to the 18th. Remember, when you want to do exponents, you have the keyboard button here, which has an exponent button in it. But also, if you use the caret, remember the caret is also the number 6 right above the T and the Y on the keyboard. If you use the exponent, it's going to move your cursor up into the exponent mode there. So when I'm at M, I just do Shift 6, and then it puts me up in the exponent. It's kind of nice because you don't have to grab your keyboard. I know most of you grew up on the internet, so you're using the computer all the time. But, you know, people, computer scientists and people who spend lots of times on keyboard, it takes you a lot of time to be reaching for the mouse all the time. If you can do everything with keyboard shortcuts, save yourself a lot of time. So Shift 6 or caret puts you up there. We'd go 18. Let's see if this is right, which it is right. But and there we go, right? And they do the same explanation as me. Oh, this m to the 6th to the 3rd means 3m to the 6th is multiplied together. That's really 18 of them. So see how they're just doing a bigger example of what I showed you, because that's kind of the way to think about it. But then here's how we actually do it, where we know, oh, I'm supposed to multiply those together. Okay, let's look at the next problem. Oh, just so you know too, it was pointed out to me that the Delta Math stopped showing videos with the homeworks. So what had happened was my license that I bought a year ago for Delta Math had expired. So the way Delta Math works is I pay for Delta Math, but the students don't pay anything. That's one reason we're using it, is because it saves students a ton of money, right? In some of the classes, it's like $100 just for the computer use. But this one works where the students pay for, or the teacher pays the license and then the students get to use it. Anyways, my license expired at the beginning of October, and it didn't like tell me that my license had expired. So I just renewed another 1-year membership. So you'll see those videos showing up again. So please look for those videos if you're having trouble. I know some people might have got used to like them not being there and then you don't look for them anymore, but just make sure you watch the video because they're available again, right? That one works. It should give me something. It's going to keep giving me these. Let's see. So there's that. Here we go. Basic exponent rules. Okay, so this one, it's mixing it up a little bit, right? It's kind of like mixing things up. So here's a different rule. We just did a few examples where we're using those same rules each time. So here we got to go. This is a different exponent rule, but it kind of looks like one of those ones that he showed us. So you're going to go back over here, and you're going to go, it's kind of like this one, right? X to the n, x to the m, where this is 5 to a power times 5 to a power. So this is going to be what? Now, usually if we have a number to an exponent, we go ahead and simplify that. But see how they're explicitly telling you they want 5 to what exponent does this become? Well, our rule tells us this is where we add those exponents together. So I'm going to make that a 7. 5 plus 2 is 7. There we go. All right, next problem. Now it's back to one of these. Okay, this is going to be 2 to the 20th. Now 2 to the 20th is a massive number. So 2 to the 20th, you probably would not multiply that out and write it all out because it gets really, really big. You'd probably leave it as 2 to the 20th, but it's obvious here how they want you to answer it anyways. Okay, new problem. Right, so they're just going to keep giving you these, right? And you kind of get used to it. Okay, now there's a different one. 2 to the 5th over 2. Now, here's where some people get confused by this. It's actually a very simple problem, but I understand why people get confused about this because you look at the exponents and you go, wait a minute. That one on the bottom doesn't have an exponent. Yes, it does. What's the exponent on that number on the bottom? It's a 1. Remember, 2 is really the same as 2 to the 1. We just don't write the 1. We understand that it's a 1 that's there. So this is really 2 to the 5th over 2 to the 1st. And if we go back to our rule here, this tells us that's where we're supposed to subtract our exponents. So see what I'm saying is people would make this mistake of saying 5 minus 0 because they don't see an exponent, but it's not 5 minus 0. It's 5 minus 1. So this should really, which makes sense. If you wrote this out and you had 5 2's on top and 1 2 on bottom, you could cancel one of those 2's. So it'd be 2 to the 4th. And 2 to the 4th is easy to figure out. 2, 4, 8, 16. 2 to the 4th is 16. So see how that's not too bad of a number to go through and figure out. But 2 to the 20th gets a little bit large. So you can see the two ways I just justified it. 2 to the 5th over 2 to the 1. You do your canceling, and you do your subtraction. But they also have it this way, where it's 5 2's on top, 1 on bottom. You cancel one set. You divide away the 2 on top and bottom, and you're left with 4. So try to challenge yourself to think about it in terms of both of those ways, because you'll just understand the problem a lot better. I think that's all of the ones it's going to show us. I wanted to do enough that I could show you all of those, but I think that's all the kind of ones we're going to see. So here we add them. Here we multiply. So it's really just getting used to, when do you add exponents? When do you multiply them? When, like this, do I subtract? So this would be a 2. If you get those basic ones down, you're off to a good start, okay? So let's go back. There was another one somewhere. Here we go. And then they build and get a little bit tougher. So this one, I think, oh, maybe this one's going to be the same. So this is going to be, oh, is this the one we just did a minute ago? They're still kind of mixing it up, but this one's with variables only. So it's pretty similar to the one we just did. But you can see still very basic problems that we're looking at, right? Let's do this one. This one's a little trickier now. Now, this is what we're going to get into when we start getting into the polynomial stuff. This what we're looking at right here is going to be really important. But you're going to get to the point where you can do these like just automatically. You'll look at it and you're, oh, I know exactly what that is, right? You just learned this stuff, so it might take you a little bit to work on it. But right now, all right, so what do? I've got 9 times 7 is 63. And then x to the 5th times x cubed, well, that's where we're going to add those exponents, so that's x to the 8th. So submit our answer. There we go. We got it, right? So see how they did it? 9 times 7, 63. Here they're adding in the 5 and the 3 from the exponents, and you're good to go. All right, what about this one? All right, we'll just break it down. How do you think about this? Well, this is negative 5x times negative 5x times negative 5x. That's 3 negatives being multiplied together. So should our final answer be positive or negative? Well, every time you multiply 2 negatives together, they cancel each other out. We have 3 negatives being multiplied together, so 2 of them will cancel each other out, and we're still left with that last negative, making our answer negative, so we're going to get negative. All right, but now we go, wait a minute, this isn't like the rule that we're used to. We're used to taking, like the problems we looked at was a base to a power to a power. So what is this? Well, that leads us into our next exponent rule, which is the following. And it looks kind of similar to the other one, so you have to be a little careful. If we have a times b to the nth power, that's like what I'm talking about in the problem we're looking at right now. So what's that going to equal? Well, let's play with it and find out. So let's make ourselves a simple example. What if I have 2x being raised to the 3rd power? 2x raised to the 3rd power. So what does that mean? That's 2x times 2x times 2x. Okay, I got to multiply all those things out. But remember, we can multiply things in whatever order we want. So I could multiply the 2's together. 2, 4, 8. Right? Sometimes people get 6. We're not adding the 2's, we're multiplying. 2 times 2 is 4, times 2 is 8. So we get 8. Oops. 8. And then I have x times x times x. That's x cubed. So this actually becomes 8x cubed. But really, there's like an intermediate step. How did we do that? Well, it really became 2 cubed x cubed. In the middle, that's your intermediate step. So what you're doing, people start to use the word distribute, but we don't want to use the word distribute because distribution in mathematics means a specific thing that involves multiplication and addition. There's no addition in this problem, is there? So we don't really want to say distribute, and it may seem like I'm being kind of harsh with the, well, why can't I just say the word? It's confusing. If you say distribute in mathematics, people think you're talking about mathematical distribution, which this isn't. But see how the 3 ends up applying to both the 2 and the x? Well, that's what we have in this problem right here. We know our final answers. Well, let's just do this one. Here, let's work it out. I've got -5 cubed. What was it an x? Yeah, -5x cubed. Okay, what does that mean? That means -5x, -5x, -5x. Oops, if my stuff's off the screen, just let me know in chat and I can move it over. Because depending on what app I'm in, I got to move stuff around. Sometimes I don't see it if I'm off the screen, so let me know. Okay, so 3 negatives multiplied together leaves us with a negative. 5 times 5 is 25. Times 5 is 125. So we have -125. And then we have 3 x's being multiplied together, x cubed. Okay, so that's going to be one way they're going to show us in the solution. But let's go back up to here. So remember, I didn't actually finish our rule here. This becomes a to the n, b to the n. Up here, the rule, you apply that exponent to each piece in there. So for us, what does that mean? Well, we could have thought about the problem this way. We could have thought about it that this equals -5 cubed x cubed. And -5 cubed would be -125. And x cubed is x cubed. So you get the same answer, -125 x cubed. So when we put that in here, it says, are you sure? Oh, I'm very sure. All right. So you see how this works out. So see, that's what we have on the one page. I just don't have the one exponent there, but it's the same thing. And then they're like, oh, here's how you do it in sort of the shorthand. So either way, you get the -125 x cubed, and that's your final answer there. Okay, so I will, like immediately, I'll go through and I'll make that extra assignment that somehow didn't get in there that has you working with the exponents a little bit more. Shouldn't take you terribly long, but it'll give you some good practice with those exponents. And then we will continue through this chapter. I think we'll be doing scientific notation next time, although I'll probably do a few more of the problems that we're looking at. We'll see. Depends what looks like people need. So otherwise, great work. And I will see you in a couple days. Anyone who wants to stick around after I close down the YouTube stream right now, hop over into Zoom. I'll leave it open for a few minutes. So if you want to come talk to me, come talk to me. Okay? All right, we'll see everybody.